This is Mr. Beck Does Your Homework. This is physics homework number 5, questions number 8, 9, and 10, a 3-part question. This one breaks from tradition. East is not positive in this case, so we're going to be looking for magnitudes instead of worrying about east and west here. But it does say, a car moving westward along a straight, level road increases its velocity uniformly from plus 15 meters per second to plus 42 meters per second in 14 seconds. Now, if this is saying that plus 15 and plus 42 and it's moving westward, I guess that this problem has already defined that west is positive. So it's moving, it increases its velocity uniformly from plus 15 meters per second. So from means my initial velocity is plus 15 meters per second to 42 meters per second. So my final velocity is going to be positive 42 meters per second in 14 seconds. My time is 14 seconds. It's asking what was the car's acceleration. So I'm looking for A equals question mark. Well, I have an initial velocity, a final velocity, a time. I'm looking for an acceleration. The equation that I have that relates those 4 variables is that my final velocity is my initial velocity plus my acceleration times time. And remember how we got this equation in the first place was rearranging. So if I want to solve for A, I subtract initial velocity from final velocity. So that's V minus V0 equals AT. And now I can divide by time, so I get my acceleration is going to be V minus V0 over T. So when I plug in my numbers, I've got my final velocity of 42 minus my initial velocity of 15 divided by my time of 14 seconds, and that's going to give me my acceleration. And it's going to be positive in Texas because we've defined left as positive, and this is a positive number, and so it's accelerating to the left, but that's positive, so that's my acceleration. The second question says, how far did it move while accelerating? Well, to answer that, I'm looking for my displacement is question mark. Can I solve for displacement when I have initial velocity, final velocity, and time? I'm going to find the equation without acceleration just because, I want to be able to solve question 9 without even solving question number 8. Now, you really could pick any equation with acceleration in it and position in it. Since you've got initial velocity, final velocity, and time, you can use any equation you want. But what I'm going to do is I'm going to pick the equation without acceleration because that'll tell me that my position is my average velocity, which was 1/2 V0 plus V, times my time. So my position is going to be 1/2 of my initial velocity was 15 meters per second, plus my final velocity is 42, and my time is 14 seconds. When I do that, I will get a rather large number that is going to be my displacement in meters. Question 10 says, what was its average velocity? Now think about that, average velocity. When something is constantly accelerating, if I had myself a velocity versus time graph, then in this case I'm starting from a higher velocity. I'm starting with 15 and I'm going to 42. So let's say I start at, this is 15 and I go up to 42. What my velocity would be doing is doing this over time. So I'm going from 15 to 42. Now what's the average of 15 and 42? It's just what you would expect an average to be. So my average velocity is going to be my initial velocity plus my final velocity divided by 2. Or as I write it in other places, I say that my average velocity is going to be 1/2 of V0 plus V. So when I have my equation that says my position is 1/2 V0 plus V times T, then I'm saying that's my average velocity times time. So if my average velocity is 1/2 V0 plus V, then in this case my average velocity is going to be 1/2 of my 15 plus my 42. And that will give me an average velocity that will be plugged into Texas.